Angle properties of a circle. Let's look at the parts of a circle. So we have a circle with center O and a line that passes through the center touching the circumference on both ends. We call that the diameter. That is, line AOB is the diameter. And OA, OB is the radius of the circle. Half of the diameter is the radius of the circle. Now the diameter divides the circle into two parts. We call them a semicircle. Now we also have other lines in the circle. We have chords. PQ, as shown in our diagram, is referred to as a chord. And the chord divides a circle into two parts, a minor segment and a major segment. And we also have an arc, which is part of a circle. Looking at the diagram here, line ADB is an arc of a circle, that is part of the circumference. Then we have a segment. The shaded region ADB is a segment which is bounded by a chord and an arc. Then we have what we call a sector, which is a region bounded by two radii, PQ, PS, and an arc, QRS. So the shaded region is a sector. This is a minor sector, and this other part is a major sector. This other part is a minor sector. This prerequisite knowledge is very important when handling this topic of angle properties of a circle. Now, the first property we have to look at is the property whereby angles subtended by an arc or a chord in the same segment at the circumference are equal. Now, we have an illustration here. Consider the chord AB. It's subtending angle 40 at C in this major segment. And the same chord AB is subtending angle X at point D in the same segment as angle 40. So the two angles X and 40 are equal. Therefore, X is 40. That is the first property whereby angles subtended by an arc or a chord in the same segment at the circumference are equal. The second chord, equal arcs subtend equal angles at the circumference. Also, equal chords subtend equal angles at the circumference. A simple illustration, consider this circle with chord PQ being the same size as chord BC. Now, chord BQ subtends angle 20 degrees at R in that segment, and chord BC subtends angle Y at point A. Now, because the two chords are equal, PQ equals to BC, therefore Y equals to 20. That is our second law. Now, the third property of a circle states that the angle subtended at the center of the circle is twice the angle subtended at the circumference of the circle by the same chord or by the same arc. Now, consider this circle. We have the arc PQ, which subtends angle 2x at the center. The same arc PQ subtends angle X at point R in the circumference. Now, the two angles relate in that the angle at the center is twice the one at the circumference. Therefore, the angle at the center is 2x if the angle at the circumference is x. Angle subtended by the diameter at the circumference is a right angle. Now, this concept, we're going to apply the previous concept whereby we say angle at the center, that is angle A or B, is equals to 180 degrees. And we know that this chord, AB, the diameter is a special chord that passes through the center. So angle at the circumference DB is equals to a half angle at the center. So therefore, the diameter will always subtend 90 degrees at the circumference. So that is another property we have to remember, that the diameter will always subtend a right angle at the circumference. Lastly, we have to look at a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral inscribed within a circle, meaning the four vertices of a quadrilateral touches the circumference of the circle, as shown by this figure. PQRS qualifies to be a cyclic quadrilateral. Now, in a cyclic quadrilateral, the opposite angles are supplementary. That is, angle A plus angle B will give us 180 degrees. Same as angle X plus angle Y will give us 180 degrees. Now let's look at this example. Now in the figure below, AC is the diameter of the circle, and we are supposed to find the unknown angle X and Y. Now if you look at this figure, ABCD is a cyclic quadrilateral. Then we also have DC is a chord which is subtending angle Y, and DC is also a chord subtending angle 20. Therefore, Y is 20 degrees, reason being angles subtended by the same chord DC in the same segment are equal. Now, if you look at this diagram, AOC is the diameter. Therefore, the diameter subtends angle 90 at the circumference. Therefore, X plus Y is 90 degrees, and we have Y as 20. Therefore, X is 70.